objective of this project is to determine the height of which to unroll a toilet paper roll at which it will hit the ground at the same time as a roll that is in free fall from 3 meters tall. For this experiment, we will be using energy to determine the height of which to unroll the toilet paper roll.
To begin with, we're going to be calculating the velocity of the toilet paper roll as it is unrolled using potential energy is equal to kinetic energy linear final plus kinetic energy rotational final. To begin with, we plug in all of the variables for kinetic energy and potential energy. mgh is equal to potential energy for gravity. Kinetic energy linear is equal to 1/2 mv squared. Kinetic energy rotational is equal to 1/2 times the moment of inertia times the angular velocity squared. The moment of inertia for a cylinder with a hole in the middle is 1/2 m times the inner radius squared plus the outer radius squared. Angular velocity is equal to linear velocity divided by the radius. We plug in the formulas for moment of inertia and angular velocity and get down variables to just mass, radius, velocity, and gravity. We can then cancel out mass as it is used in every equation. Simplifying it further, we eventually get down to 4 times gravity times the height is equal to velocity squared times 3r squared plus little r squared over big R squared. This can be simplified further down into 4 gravity times the height divided by 3 big R squared plus little r squared all over big R squared. Finally, this is simplified all the way down into the square root of 4 times gravity times height times big R squared over 3 big R squared plus little r squared. And that is equal to the velocity of the toilet paper roll as it is unrolled. To begin with, we're going to be using height is equal to velocity over 2 times time. That can also be written as time is equal to 2 times the height over velocity. For this part of the experiment, we are going to be setting time 1 is equal to time 2 because the time it takes for the 2 to reach the ground should be equal if they are arriving at the same time. You can plug this equation into time 1 is equal to time 2, and we get 2 times the height of the first roll divided by the velocity of the first roll is equal to 2 times the height of the second roll over the velocity of the second roll. This can be rewritten as the height of the first roll over the height of the second roll is equal to the velocity of the first roll over the velocity of the second roll. To find the velocity of the first roll, we're going to be using kinematics. Velocity squared is equal to v naught squared plus 2 times the acceleration over delta x. You can plug in gravity for the acceleration and height for delta x, so we get velocity squared is equal to 2 times gravity times height, or the square root of 2 times gravity times height is equal to velocity. Then we can plug that equation into v1 and this equation in for v2 to get our equation which we're going to solve for. First, we square the equation to get rid of the square roots. This can be simplified down into the height of the dropped roll is equal to 2 times the height of the roll in free fall times big R squared over 3 big R squared plus little r squared. Here are our measurements. When plugged into the equation, we get that the height of the dropped roll is equal to 1.786 meters.
This shows that our data was correct because it was in our margin of error. We assumed that the toilet paper had a uniformed radius, although it actually wasn't.